Hey students, in this video, we're going to talk about a new kind of pattern. One pattern you've learned so far is arithmetic patterns, which are linear. You should notice that each time you're adding the same number, plus 4, plus 4, plus 4, plus 4. Each one has an increase of 4. So in that sequence of numbers, the pattern is a sub 1 plus d times n minus 1, or you learn to use y equals mx plus b. However, if you take a look at the second pattern, it doesn't go up by the same amount each time. It goes up by 3, then it goes up by 5, then it goes up by 7, then it goes up by 9. So this is not a linear sequence. But if you take a notice, this is 2 higher than the previous one, this is 2 higher than the previous step up, and that's 2 higher than the previous step up. That second difference is 2. This means it's a quadratic pattern. Quadratic pattern. A quadratic pattern means you have x squared, or for the sake of the day, we're going to use n squared, as in n representing the number in your sequence. First number, second number, third number in your sequence. Let's look at that now. First question, we're going to write an equation for these quadratic patterns. If you notice, the first step has 1, 2, 3, 4, 5 squares. The second step has 1, 2, 3, 4, 5, 6, 7, 8 squares. The third step has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 squares. We're going to first check to see if it's quadratic. I'll first go up by 3. From 8 to 13 is going up by 5. That second difference is plus 2. This is quadratic. Now that I know it's quadratic, these are the steps to write an equation for that quadratic sequence. I'm going to rewrite those numbers here. 5, 8, and 13. This is step 1. So we're going to write that. We're going to compare how far these numbers are from 1 squared. Keep in mind, quadratics deal with that stage number squared. So I can compare that to 1 squared, compare that 8 to 2 squared, compare that 13 to 3 squared. I want to know how they compare by subtracting them. So I'm subtract each one of those numbers from the original numbers in the sequence. So 5 take away 1 squared, that means 5 take away 1. So it's 4. 8 take away 2 squared, 2 squared is 2 times 2. So that's 4. So 8 take away 4 is 4. And then 13 take away 3 squared, 3 times 3 is 9. So 13 take away 9 is also 4. So if I understand that, I can simply write my formula is the stage number squared plus 4 more. So if you check it out at stage 1, 1 squared is 1. If you add 4 to it, you get 5. 2 squared is 4. If you add square to it, you add 4 to it, you get 8. 3 squared is 9, you add 4 to it, you get 13. So this formula is working for all the numbers in that sequence. First step, I have 3 squares. The next step, I have 1, 2, 3, 4, 5, 6. I have 6 squares. The next step, I have 1, 2, 3. This is 9 in the middle, plus 2 more, so it gives you 11 squares. So, plus 3 the first time, plus 5 the next time. That second difference is plus 2. So again, this is quadratic. Because it's quadratic, I'm going to use these numbers, 3, 6, and 11. I'm going to compare them. Each time I take my step number and then square it. So that's step 1, it's going to say 1 squared. That's step 2, relates to 6, it's going to say 2 squared. Step 3 relates to 7, relates to 11, so it's going to be 3 squared. Then this is always again a step number squared. I subtract them. 3 subtract 1 is going to be 2. 6 subtract 2 squared is 4, so 6 subtract 4 is going to be 2. 11 subtract 3 squared is 9, so 11 subtract 9 is 2. Each time I'm adding 2. So apparently, since it's all the same, it's going to be step number squared plus 2. It should give me outputs for the sequence. If I check it out, 3 squared is 9 plus 2 gives you 11. It matches. 2 squared is 4 plus 2 more gives you 6. It matches. 1 squared is 1, plus 2 more gives you 3. It matches. So it maps to all the numbers in that sequence. On the first step, I have 3 squares. On the second step, that's 8 squares. On the next step, I have 1, 2, 3, 1, 2, 3, 4, 5. So it's going to be 15 squares. The first time, it goes up by 5, and then the next time, it goes up by 7. The second difference there is plus 2. So I know that this is quadratic. I'm going to take the original numbers, 3, 8, and 15. I'm going to take the stage numbers. Stage number squared. So like stage 1, or step 1, is 1 squared. Step 2 is going to be 2 squared. Step 3 is going to be 3 squared. I'm going to get the difference of those. So 3 take away 1 is 2. 8 take away 4 is 4. 15 take away 3 is 6. This is not the same number every time as in the previous two. In the previous two examples, each number was the same. This is truly an arithmetic sequence. So if you look at this, it's plus 2 each time. So I know it's an arithmetic sequence. So I'm going to use my arithmetic sequence formula. A sub 1 plus d times n minus 1. My a sub 1 value is 2. My common difference is also 2 times n minus 1. After I distribute the 2, I get 2 plus 2n minus 2. Combining my like terms, the 2's cancel, giving me just 2n. This is my linear section, a linear part to the graph, the equation. So the first half of the equation is the quadratic part, into the second power, stage number squared, plus 2 times n, 2 times that stage number. So this formula should give me all the numbers in that sequence. So keep in mind, n to the second power plus twice n can be used to find all the numbers in the sequence. If you check it out, 1 to the second power plus 2 times 1. 1 to the second power is 1, plus 2 times 1, that is 3. 2 to the second power plus 2 times 2. 2 to the second power is 4, and 2 times 2 is 4. You add them together, that does give you 8. And then stage 3 is 3 to the second power plus 2 times 3. That's 9 plus 6. That does give you 15. So it's a stage number squared plus twice that stage number. And that's the formula for this sequence. All right, I'll give you another one. Looking at this, the first stage, or first step, we have 4 squares. The next step we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 9 squares. The next one we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 squares. I'm going to count that again and make sure I'm right. So if I check it out, it's going to be up 5. It's going to be up 7. That common difference is up 2. Using what you learned, you should find that this is going to be 4, 9, 16. I'm going to take my stage numbers, n squared, stage number squared. So 1 squared, 2 squared, 3 squared. Let's subtract them each. 4 take away 1 is 3. 9 take away 4 is 5. 16 take away 9 is 7. This is a linear sequence. So I'm going to use my arithmetic formula for it. So this should be 3 plus my common difference is 2 times n minus 1. 3 plus 2n minus 2. 2n plus 1. So this is my linear section. And it's going to be my stage number squared plus 2 times my stage number plus 1 should give me all the numbers in that sequence. Other than a table, as a sequence of pictures, they could give it to you as a sequence of points. The x value is the stage number, and the y value are the numbers in your sequence. So the numbers in my sequence are 2, 11, 26, 47. This is at step 1, step 2, step 3, and step 4. Or stage 1, stage 2, stage 3, stage 4. If we compare that, this is up 9, this is up 15, and this is up 21. 41 take away 16 is up 21. So it is up 6 here, and it also is up 6 here, so plus 6. In this case, it's not plus 2 each time, it's plus 6 each time. That's still quadratic. The reason why it's still quadratic is that growth is the same at the second level. The second difference is the same each time. It's still quadratic. It does change a bit about our formula, though. Since that's 6, that changes the coefficient. It changes the coefficient of the n squared term. Coefficient of n squared is always going to be whatever that common difference on the second level is, divided by 2. So it's going to be 6 divided by 2. It's going to be 3 in front. That means my formula is going to start off as 3n squared. My coefficient of n squared term should be 3, because now it's 6 up front. And then I'm going to rewrite all these numbers again. So 2, 11, 26, and 47. What you want to do is, instead of having just 1 squared, it's going to be 3 times 1 squared, because that's step 1. There's going to be 3 times 2 squared, so that's step 2. 3 times 3 squared, and then 3 times 4 squared for each one of those steps. I'm going to get the difference between both of those. Again, that's 3 times the stage number squared. And there's going to be 2 take away 3, which is going to be negative 1. That's going to be 11 take away 3 times 4, that's 12, so that's going to be negative 1. All right, that's going to be 9, so 3 times 9 is 27. 26 take away 27 is negative 1. And that's going to be 12, and 3 times 12 is 47 take away 48 is also negative 1. Here, my common difference each time is negative 1. So apparently, take away 1. My formula for this is going to be 3 times the stage number squared, take away 1.